So now we need to create an assembly to bring our master sketch into and also bring in the master tubes or the individual tubes that we're going to use to build our assembly. So the first thing I'm going to do is I'm actually going to go and create a new assembly. And we're going to keep this pretty generic. It's already asking me to bring something in since we have nothing there. I'm going to name this assembly file as just main assembly. Okay. And then the first thing I'm going to do is insert components, and I'm going to bring my master sketch in. If I click while this is floating around, it will just drop it wherever it is. If I go and hit the check mark, it'll actually automatically align this origin with the origin of the assembly. So everything is kept in the same context as when you created it. Not a super big deal, but just keeps everything nice and clean. So now we have our master sketch inside of our assembly. Let's go ahead and save. And now we need to bring in some tubes. So how many tubes are we going to have in here? We're going to have 1, 2, and then 3. And the third one's going to have this bend in it. So what I'm going to do is I'm going to go to Insert Components. And before I bring just this master tube in here, I want to leave this one unaffected. This is kind of my copy and paste file. So what I'm going to do is right-click, copy. You can do this with your keyboard as well. Paste. I'm going to paste it again. And paste it again. And I'm going to name these tubes what I want them to be. So let's call it T1. And then the next one, let's call it T2 and T3. So now we have our 3 tubes named T1, T2, and T3. And if we later decide to bring another tube in, we can copy and paste our master tube and hit T4. So really all the master tube is a copy and paste template so you can continue. So let's bring in T1. Okay, now this is extremely important part of what is something that is really easy to make a mistake on is you want to make sure that you're mating your tube to the sketch of the tube. And the reason why is because eventually we're going to be normalizing the surface, meaning we're going to be replacing the surface with surfacing tools in SolidWorks, and then all of a sudden your assembly is going to forget where the heck everything is, and the only way to avoid this and to not get any errors is to mate it with the actual sketch vertex itself. So I'm going to take that and I'm going to either mate it on this point or this point. So let's hit mate. Once again, another really important thing is use the sketch again. I can either use the inside or outside profile of my sketch and mate it to the line. And this is a good example. It flipped backwards, so let's go ahead and mate alignment. Let's flip it around. Okay, and hit check. And then you can see, because of the way we have it mated, we can kind of rotate this etch where we want it. Now, the name has a new tube. The moment we hit save or rebuild, now look at that. This is the super cool part. T1 took effect. So that is the name of the file, because our master file has this all built into it. When we copy and paste this and we change the name to T1, it automatically updated the T1. This is super cool, especially if you have extremely big chassis or assemblies. You could just have this part numbering just automatically happening in the background, and it's all matched up to your file name, and it's on the tube. Pretty cool. So let's go ahead and bring in the next tube, T2. Okay. Let's mate on the actual sketch itself. We're not mating on the surface of the tube. This is so incredibly important. And later it's because these surfaces will get recreated and SolidWorks for some reason will not be able to remember where that surface was. You'll be like, it's right there, but really it has no idea what surface it is because you recreated it. So we need to stick with the sketches because the sketches are not going to change. Okay, so here's our second tube. Rotate it where I can see the part number. I can hit rebuild, and now it's going to take T2. So what's cool is because we copy and pasted this master tube so many times is these are individual parts. So if I make a change to T1, it's not going to change the T2. They're completely separate. We just use the master tube as a way to create the start of that tube so we didn't have to manually draw a new part every single time. And these features are already kind of built into it. Okay, so what I'm going to do first is, before I put that third tube in, I'm going to go ahead and get this T1 tube to go the length that it needs to. So I'm going to take T1 and I'm going to edit just T1. Okay, so right now all this other stuff is here, but I'm only editing this one. You can see it's blue over here. I can actually go into the original feature and change this from blind, where we had 4 inches, and go to vertex. Boom, now it's the full length from vertex to vertex. Now, just so you don't get confused, we could have done this a different way. Let's go back. Let's put this back to 4. Oops. And what we could do is we could create a sketch on the end of the tube, convert entities of the outside-inside profile, so if anything changes, it'll follow it. And then we're going to extrude this up with vertex. We're essentially doing the same thing, but we just added another feature into the feature tree. And there we go. Now, it's okay to select the body of the part you're working on to create sketches. You just never want to do any mates that are related to the bodies. You want to use sketches only for the mates. And you will see later why it's so important. I cannot iterate enough. It'll create a nightmare if you have 100 tubes and all of a sudden you go to normalize everything and it's all going to start losing what surfaces it was built onto. Okay, so the next thing I'm going to do is I'm going to bring in my T3 tube. So this is the last one we haven't touched. And I'm going to bring it in down here. Okay, mated the sketches together. I'm going to click the sketch to the line. It's flipped the wrong way, so I'm going to flip it over. Alright, so here's a cool example of my master tube was too long in the first place for this thing. So I can actually go back into the blind feature, the 4 inches that we created in the master tube, and just shorten it up so it's below the dot, or where the start of the bend is. Another way I could do this, if I don't want to just guess with numbers and I want it to follow it, I could just change this from blind to up to vertex and click the vertex. So now whatever I do to that sketch line, it's going to follow it. So the next point that we need to do is we need to sweep this tube. So what I'm going to do is I'm still editing just T3. I'm going to click this surface. I'm going to convert the inside, or the outside and the inside. Then I'm going to click on the down arrow on the sketch and click 3D sketch. And now I'm going to convert entities of the line I want it to follow. We already have this down here, so we're just going to click the line that we want to keep going on. Okay, now I can click the profile. I hit swept boss, and then I can then click the 3D sketch. Now you can see we are building a bent tube. Okay, so one thing I want to show you is because of how I did this extruded to the vertex, if I change this radius, obviously this vertex is going to move down. What's cool about making this one extrude up the vertex is that if I make this radius change, which I'm going to, if you remember correctly, this was actually modeled, I modeled this at 6.2, but in our bend CLR chart, it was 6.22. So now I'm going to change it to 6.22. And when I undo it and I rebuild it, this actually follows it. I know it's such a tiny move, you can barely see it, but I can assure you, if I look at it direct on, the vertex is right in the center of that bend, or bend start. So it kind of makes it more powerful so that it follows. The next thing we're going to do is we want this tube to cope onto this tube. So let's minimize this. So we've got a really clean setup. We got our master sketch. We got tube 1, tube 2, and tube 3. So on tube 2, if we edit that part, it's going to be very tempting. I can go back and edit this boss extrude to do this. Change it from blind and go to up to surface. It's like, wow, that's awesome. Like, I've got a notch. Like, that's a huge shortcut. But no, you cannot do that. You have to go to the vertex. The reason why is that right now it looks nice and pretty, but then when I go back and make this tube into a normalized tube, which you'll see later, it's going to not be able to find this surface, which will drive people nuts, but it'll cause you an error on every single one of those notches. So just make sure you're always using the sketch itself to drive these things. It's so important. So here we go. So now we have this set up here, and the way I'm going to notch this, I'm going to notch it manually. I'm going to go in, and I was already editing this. Let's go back to Edit T2, and I can draw, let's grab a feature. I can make a plane. I'm going to click that vertex in the line so that I can look straight down this tube. So you can see I'm looking straight down that tube. And if I want to, I can just convert entities this, and it puts the diameter of the tube there, or I could be a little bit more specific if I don't want it to be driven off the tube and just put 1.75, which is what I'm going to do, because if I did it the other way that I just showed you where I convert entities, this may disappear later on when we do the surfacing, which will make a lot of sense later. So we exit the sketch, extrude cut, through all, and because we're only editing this tube, it's only going to modify that tube, and boom, we have a notch. So this is the very first step of our main assembly. Let's go ahead and collapse all this. And what we're going to do in the next video is we're going to go ahead and go in. We showed you the basic notch right here. We're going to go in and we're going to do a miter on this end, and we're going to do another notch here as well.